week we're going to be looking at Dalton's Law. This is on page 314. This is experiment 10.4. Remember last week we did Charles' Law and Boyle's Law? So we're looking at Dalton's Law. This is the last one we're going to do from chapter 10. So we're going to start with the paragraph on 314 that builds into that experiment. It says, let's pull this all together in a final experiment that will allow you to use Dalton's Law, the vapor pressure of water, and the ideal gas law to figure out the concentration of hydrogen peroxide in a bottle that you buy from the drugstore. To do this, we will let hydrogen peroxide decompose according to the following reaction. 2H2O, 2 aqueous, yields 2H2O liquid plus O2 gas. This is normally a very slow reaction, but the addition of yeast speeds it up considerably. We will add yeast to hydrogen peroxide and capture the oxygen produced in the balloon. The volume of the balloon, along with the pressure and temperature, will tell us the number of moles of oxygen produced, which will tell us the number of grams of hydrogen peroxide in our sample of solution. Okay, so what we need for this is the mass scale, which we have, a thermometer, hydrogen peroxide, yeast, a plastic bottle, a round balloon. It calls for a turkey baster, but they're basically using it as a funnel, so I've got a funnel. It calls for string, scissors, and a ruler to measure the balloon, but I'm just using a measuring tape instead. Someone to help you, and a weather report that's going to tell us atmospheric pressure, which we'll have to look that up while we're doing this project here. So we'll have to get back to you about that. Okay, so.
And we are trying to measure what again?
We are measuring the concentration of hydrogen peroxide. Okay, so we're going to put the balloon in an open end of a turkey baster like we did in experiment 7.2, then remove the bulb. So you basically create a funnel here. Holding the balloon to the baster, pour about a teaspoon of yeast into a baster so it falls into the balloon. So we're going to basically pour all this into the balloon. Make sure it all goes in. And that's all done. That was easy. Okay, let's see. Turn the entire assembly upside down so the yeast falls. Oh, okay. Sorry. If something gets stuck in the baster, turn it upside down. Yeast to fall in the balloon. Okay, sorry about that. Put the bottle on the mass scale and turn it on. So we're checking the weight of the bottle. I want to find out how much this weighs. Fine, I should have done this ahead of time. Sorry, guys. And it's going to be 8.4. Yeah, 8.4 grams. So mark down 8.4 grams under your data. Okay, now we're going to carefully pour hydrogen peroxide into the bottle. Make sure all of it goes in because you need to know what the mass of the bottle is. So we need to have, we want to make sure that goes up to, the mass scale reads something more than 100 grams but less than 120 grams stops. So we want to get it to more than 100 grams but less than 120 grams.
8.4, right?
So we're going to stop at that point. Yeah. Okay, so we're at 100 and okay, so it says we want to record the mass now. So at this point we are at 100 and let's see. Sorry, that's just not here.
Why did you shut off recording?
Sorry, you just have to wait. Okay, we're doing the experiment together here. Okay, so we're at 116.3. So 116.3 minus the initial weight, which was what? 8 point.
See, I was trying to ask you about that.
8.4, I think.
8.4.
That's what I thought.
So 116 minus 116.3 minus 8.4. So that'll be your actual amount of, if that's your mass of the hydrogen peroxide. Now we're going to put the balloon on the bottle so the balloon's opening forms an airtight seal against the bottle's opening, just like you did in 7.2. Don't allow any yeast to go inside just yet. So all of it's like that. I've got this here. Okay. So it looks like this now, similar to the other experiment we did where we did the 3 balloons on the 3 different bottles. Okay. Once the balloon is securely fastened to the bottle, lift up the balloon so the yeast falls into the bottle. I guess I'm doing this on top of the scale. It doesn't say whether I should take it off. Does it? Okay, I guess not. So hopefully there's space here. We have to leave the space here. All right, so we're going to now lift this up. Let me make sure it doesn't ask for the mass. I'm sorry, 1 second here. Can you pause for a second? Sorry, guys, I'm going to pause a minute. Okay, so we're going to now put this in. And as you can see, it's starting to react a little bit. It's sitting on top. And what it tells us to do then is gently swirl the bottle so it creates a reaction. But we have to be careful we don't let the bubbles rise too much that any yeast goes into the balloon. Because you can already see actually some gas is being formed here already. So we're going to just keep swirling it until we get some more of this mixing in. Whoa. Okay.
Magic.
Yes. All right, and keep swirling until the bubbles start to form. Now this process, according to the book, is going to take about 10 minutes. So I'm going to start on this now, and eventually we'll get off, and then I will we'll stop off, and I'll keep swirling until we've filled up the balloon entirely. But you can see, we'll keep it on for a minute longer actually, so you can see how this is working. Some more in. You can see the balloon is starting to fill on top there. The bubbles are starting to rise.
Makes a great hissing sound.
Mm-hmm. You can hear the hissing. Okay, so you can see the balloon starting to expand. We're going to get off for a few moments, and we'll get back on once this is all basically dissolved. Okay, so what we now know is this is basically dissolved everything. The bubbles have finished forming. We've got a decent amount of gas in here, so we're going to measure the size of this. I could probably measure in centimeters. Go with the official amount here. Come on. Let's try this. Holding this up right. Come on. Sorry, guys. Thank you for doing that. That's for helper. Okay. So it is 38 centimeters around. Okay, so that's your measurement now. They asked us to do that. So the 38 centimeters. That's the circumference of the balloon. We're supposed to read and record the temperature of the room from the thermometer. And that is currently 27.4 degrees Celsius.
So 24.8 degrees Celsius is the room temperature?
What's that? What's that, say again?
That's the room temperature, right?
Yeah, the room temperature is 23.4 degrees Celsius. It says then to look up the vapor pressure and of water for the temperature you just read. You will need to round it up to the ones place to make it consistent with the temperatures. If the table on page 311 doesn't contain the temperature of the room, look at a more detailed table at the back side of the cover of the book. So look at page 311. What was the number I just said? 23.4?
Sounds right.
Okay, and so at 23.4, I guess we round down. So the vapor pressure then is 21.1. We need to round it to the ones place to make it consistent, right? So yeah, so it should be 21.1 is the vapor pressure. And now we need to convert that temperature to Kelvin. Record the atmospheric pressure from the weather report, and that is 29.83. It says if the atmospheric pressure in the weather report is not at ATM, we have to convert it to ATM. You will need one of these conversion factors. 1 ATM equals, we're going to use, our measurement was in HG, so that was in 29.83 in HG, so we're going to use the 1 ATM equals 760.0 millimeters HG. So now we have to translate this, you have to do your calculation for that. So 760.0 times 29.83. And then you're going to convert the vapor pressure to ATM, atomic mass units. So you have to do this in your own calculations. As discussed before, you did the experiment. You need to know how much oxygen is produced. Thus, you need to know the pressure, volume, and temperature. You have the temperature, which you converted to Kelvin in step 16. So you have to make sure you know how to convert to Kelvin. And we're going from Celsius, so it should be a pretty easy conversion. So you have to do that under calculations also. The balloon is flexible, so it expands to keep the pressure roughly the same as the outside pressure. Thus, the atmospheric pressure is essentially the same pressure inside the balloon, and you convert that to ATM in step 18. However, this isn't the pressure of the oxygen, it's the pressure of the oxygen and the water vapor above the solution. To get the actual pressure of the oxygen, subtract the vapor pressure of water, converted in ATM in step 19, from the atmospheric pressure converted to ATM in step 18. So you have to take your time and go through your calculations to do this. What we'll do is I'd like everybody to work on this now, and then we'll double check our results tomorrow in class. We still need the volume of the balloon. To get that, make sure the length of the string is in centimeters, which I did tell you the centimeters. Convert the circumference into the radius by dividing the length of the string by 2 pi. Then convert the radius of the balloon into volume by using the equation volume equals 4/3 pi radius to the third power, or cubed. Remember, a centimeter cubed is not the same as milliliters, so what you got in step 23 is also the volume in milliliters. Convert that to liters. Use the volume and just convert it to liters, the pressure you calculated in step 20, and the temperature you converted to Kelvin in step 16 in the ideal gas law to get the moles of oxygen produced. Use the chemical equation given right before this experiment to convert moles of oxygen to moles of H2O2. Use the mass of H2O2 to convert to grams. This tells you the number of grams of H2O2 that actually decomposed. Divide the mass you got by the original mass of the solution, then multiply by 100, which is exact. This gives you the percentage of the solution that was actually hydrogen peroxide. Most drugstores start out at 3% hydrogen peroxide, so this is 3% as well. But since the hydrogen peroxide decomposed, the actual percentage of your solution is probably less than 3%. So we just clean up our mess. Do all your calculations, and we'll check with the numbers we calculated when we meet in class. Thank you.